So we're going to look at rational functions, and this is a chart that is going to enable us to kind of do every little aspect of rational functions in the same place. So the first video is going to be on expanded versus factored form of these rational functions. And just to kind of remind you, a rational function is a function that is actually a fraction that has a polynomial in the numerator and a polynomial in the denominator. The base word of rational functions is ratio. So a rational function is basically a function that can be written as a ratio, and it's a ratio of two polynomials. So we're going to look at these rational functions, which are all, you can see, fractions, and we're going to convert from expanded to factored form and from factored back to expanded. And the reason we need both formats is because each one of these formats tells us something a little bit different about the function itself and enables us to find one of these other aspects, like the y-intercept, the horizontal asymptote, the vertical asymptote, the holes, the domain, the roots. Those are all things that we can determine based on the actual equation or the actual function itself, but it's a little bit easier for some of these in one form than it is the other. So let's look at the first one. And in the first one, we're going to go from expanded form, and we're going to use red for expanded form, and we're going to convert to factored form, which I'm going to use green. So let's look at this first rational function. We have x minus 4 over x plus 2. Now x minus 4 over x plus 2, that's the expanded form. There are no factors there visibly that we have as a product like you would see here in number 5. So the question is, can I factor this any more than it's already factored? And if I look at this, the answer is no. This is already factored. It's actually two polynomials, but the polynomials are in simple form, and there is no way I can factor this anymore. So the factored form is actually going to be the same as the expanded form. So that's all we do for that one. So let's look at number 2. Same situation. This is already factored as far as we can factor it. There are no additional steps I can take, no additional simplifications that I can do with this to make it any different for factoring. So it's actually going to be the same thing, x plus 6 over x minus 6. This is not always going to be the case. It just happens to be the case for some of the ones that we're seeing here in the beginning. Number 3, same situation. This cannot be factored. There are no common factors for me to factor out. It's already simplified. So the factored form is the same. It is 2x plus 5 over x minus 1. And you'll see the same holds true with number 4. So I have negative 4x plus 2 over negative x plus 1. So that's converting from expanded to factored for the top few. So let's look at some of these on the bottom that are a little bit more complex, and let's do some converting here. So I have x squared plus 2x minus 8 over x squared minus x minus 2, and I want to convert that to factored. So that's number 7. So I'm going to take number 7 here, and I've written number 7 out so we can see a little bit more clearly. It's right here. This is number 7. And we're going to convert this from expanded to factored. Now remember, when we practiced factoring, we used MF-DARM, which is a possibility, but we don't have to do the full MF-DARM here, which is multiply, factor, divide by a, reduce, and move, because our a values in both of these polynomials, these trinomials, is 1. This is 1x squared and 1x squared. So when the a value is 1, you don't have to do all of the extra steps. So let's look at the first polynomial in the numerator, and let's take care of that one first. So this one is written out as x squared plus 2x minus 8. What I want to do is take this trinomial and convert it to factored form. So I'm going to take, since the a value is 1, I don't have to do the multiplying. I'm going to take the 8, which is my c value, and I'm going to find factors of 8 which would be 8 and 1 and 4 and 2. And I'm looking for two factors of 8 that, if you look at the signs, subtract or have a difference of 2, which is my middle term. 8 minus 1 is 7. 4 minus 2 is 2. So my two factors are going to be 4 and 2. So I have x and 4 and 2. Again, I factored the c term. I didn't need to do multiply a times c because my a value is 1. I factored the c term, so we had 8 and 1 and 4 and 2. Then because my c term is negative, that dictates what I'm going to do with the factors. Since it's negative 8, I'm going to subtract the factors. So I'm looking for two factors that have a difference of my b term, which is 2. Now I want positive 2. So that means of my two factors, since this is positive, and I'll use a different color so you can see it. Since this is positive, that means the larger factor has to be positive. So there I have a positive, and I have to have a negative for the other because my c term is negative. When your c term is negative, you have to have different signs. When your c term is positive, it's either positive, positive, or negative, negative. Because when you multiply this value times this value, you have to get this one. And in order to get a negative number, I have to have a positive times a negative. So positive 4 times negative 2 gives me negative 8. So I've just factored the numerator. So that's my numerator. So now let's factor the denominator. So I'm going to look back over here at my denominator, which is x squared minus x minus 2. So I've got x squared minus x minus 2. And I'm going to follow the same format. My a value is 1, so I don't have to do the multiplying of a times c. So I'm going to take my c value, which is 2, and I'm going to find factors of 2. And that's not going to be hard because there are only 2 and 1. I'm going to look at the sign of my c term, which happens to be negative. So that means I'm going to be subtracting these terms. And I'm looking for a value of, and since this is minus x, that's the same as 1. So I know I'm going to have x, and my two factors are going to be 2 and 1. So to determine the signs of my factors, I know they're going to be different. If one is positive, the other is going to be negative because I have a negative c term. And in order to get negative 2, I have to multiply a negative times a positive. My b value is negative. That means the largest one, which is the 2, will be negative. And then since it's a negative c value, that one will be positive. So I have now found my numerator and my denominator. I'll put the little line here. So you know that's the denominator and that was the numerator. So I'm going to combine them into my factored form. So my factored form for this function is going to be x plus 4 times x minus 2, that's your numerator, over x minus 2 times x plus 1, which is your denominator. I have now completed factored form for number 7. So I'm going to come back on my paper and I'm going to enter this in for my factored form for number 7. So number 7 is going to be x plus 4 times x minus 2 over x minus 2 times x plus 1. And that is converting from expanded to factored. So let's look at number 8. We've got another situation, same thing. So I'm going to look at number 8, and I've written number 8 out again as well so we can see it. And again, we're going from expanded to factored. So I'm going to take the numerator, which is x squared minus x minus 6. Again, these are all nice and set up with an a value of 1, so you don't have to do the multiplying a times c first. So I'm going to take my c value, which is 6, I'm going to factor it, and it's 6 and 1 and 3 and 2. I'm going to look at the sign of my C value, which is negative, to determine what I'm going to do with these factors. I'm going to look for a difference of these factors that gives me a B value of 1, because that's 1x. So 6 minus 1 is 5, 3 minus 2 is 1. There we go. So I'm going to have x and 3 and 2. Now once again, because the C value is negative, that means that you're going to have a negative and a positive here. So let's look at our B value. We are looking for a negative 1. That means that the larger factor has to be negative, and since the C value is negative, the other one's got to be positive. So there is your numerator. So let's do the denominator. The denominator is going to be x squared plus x minus 2. Once again, your A value is 1. You don't have to multiply A times C. So I'm going to take the 2 and factor it. It's pretty simple, 2 and 1. And then I'm going to look at the sign on my C value, which is negative. So I'm going to do the difference. And it's plus 1x, so I'm looking at 2 minus 1, which is 1. And that's what I'm looking for. So my two factors are x, and 2 and 1. And then I'm going to look at the sign of my B value, positive. That means the larger one has to be positive, and because the C value is negative, negative. There is your denominator. So I'm going to write these in full factored form. My numerator is x minus 3, x plus 2, over x plus 2, x minus 1. And that is factored form for number 8. That's factored form for number 8. So I'm going to come over on my paper for number 8, and I'm going to write my factored form, which is x minus 3, x plus 2, over x plus 2, x minus 1. So those are my factored forms. So I've got two more. I've got number 9 and number 10. We're going to go ahead and complete those as well. So let's look at number 9. Once again, we are in expanded form and we are converting to factored form. So I'm going to take my numerator first. I've got x squared plus 7x plus 12. I don't have to do MF darm because my A value is 1, so let's factor the 12. 12 is going to be 12 and 1. It's going to be 6 and 2, and it's going to be 4 and 3. So I'm going to look at the sign of my C term, which is plus. So these are all added. And I'm looking for two factors that add up to 7. So 12 plus 1 is 13, 6 plus 2 is 8, 4 plus 3 is 7. There we go. So I'm going to have x and 4 and 3. And then I'm going to look at the sign on my B term, which is a positive. That means at least the biggest factor should be positive, the 4. And because my C term is positive, that means these have to be the same sign. So if one's positive, so is the other. I have to get positive 12 when I multiply this one times this one. So they have to be the same sign. So that is your numerator. So now let's look at the denominator. The denominator is x squared plus x minus 6. So I'm going to take my C term, the 6, I'm going to factor it. I'm going to look at the sign of my C term, which is negative, which means I'm going to be subtracting. And I'm going to be looking for 1. And once again, I didn't do A times C. We're doing simple examples right now, so we don't have to do the multiply A times C. I need something that's going to give me 1. This gives me 5. This gives me 1. So 3 and 2 are the values I'm going to use. 3 and 2. And now I'm going to look at the value of the B term, which is positive. So that means the largest factor has to be positive. But since I got a negative 6, a negative C term, that means the two values have to be opposite signs. So now you've got your factored form, which is x plus 4 times x plus 3 over x plus 3 times x minus 2. And that is your factored form for number 9. And we're going to write that in our table, and then we will do number 10, and then we will move on to the next video. So the factored form for number 9 is x plus 4 times x plus 3 over x plus 3 times x minus 2. All right, we're moving along. We got one more to do. Let's look at number 10. So let's look at getting number 10 factored in factored form. Well, if I look at the numerator, x plus 4, that doesn't need to be factored. It's already set up for us. So really the only thing I have to factor is the denominator, which is x squared plus x minus 2. So I'm going to take that 2, and I'm going to factor it. And again, 2 and 1 are my only options. I love it when they're prime numbers. I'm going to look at the sign of the C term, which will indicate subtraction of my factors. And it's plus x, which is like 1x. I'm looking for two factors that give me 1. And that's what I have. So I have x and 2 and 1. I'm now going to look at my b value, my b term. That becomes the positive. Because it's a positive term, the largest factor has to be positive. But since my c value is negative, one's positive, one's negative. So since I didn't have to factor the numerator, I already have my answer. X plus 4 is your numerator. And I'm going to put parentheses just for fun because that helps me out. Over x plus 2 times x minus 1. And that is factored form for number 10. So let's go in and update our table. So we have x plus 4 on top. And we have x plus 2, x minus 1 on the bottom. And that is the first step in rational functions, how you convert from expanded to factored form.